Welcome to SDC EMEA. My name is Rochelle Olvers, and I'm the chair of the Scalable Storage Management Technical Work Group within SNIA that produces the SNIA Swordfish specification for managing storage systems. Today, I'm going to talk about what's going on within the SNIA Swordfish ecosystem. In particular, the work we did last year and that we're working on now and over the next 6 to 12 months, focusing on expanding functionality to cover NVMe, NVMe-oF fabrics, and work on expanding into storage fabric management. What is Swordfish? To begin with, I'll explain by talking about Redfish. Swordfish is an extension to Redfish. We leverage all of our base functionality and capabilities from the Redfish specification. The Redfish specification is built by our partner organization, DMTF, and it's a REST-based specification for managing servers, data centers, and fabric management. It's designed with a JSON payload and represented in 3 different potential schema structures on top of that, using either CSDL, JSON, or YAML for those who would like a choice of, basically pick your preference for the schema type that you like. Swordfish then extends the Redfish specification, focusing exclusively in the storage schema space. We leverage all of the protocols defined in Redfish, which covers HTTPS, security services, account services, all of log services, all of the base functionality that's common to server storage, data center, fabric management are provided by the underlying specification and the underlying Redfish specification. And that allows the storage team to focus on the storage specific functionality within the Swordfish specification, extending the Redfish functionality to cover servers, storage, and fabrics together. It also includes functionality to provide the capability for class of service-based storage management. That's service level configuration, intent-based management, provisioning, and monitoring, and automated capabilities. We also have extended functionalities through our alliance partnership with NVM Express to cover NVMe and NVMe-oF capabilities. I'll describe a lot of that functionality today, as well as some other capabilities that we are planning to add through additional alliance partnerships in the areas of storage fabric management. How is Redfish structured? Everything is based off of the /Redfish/v1 hierarchy. From there, we have 3 basic core points for any element in the system. This example shows how to model a system. So think of that as a server. And these would be the 3 major points that you would go to find where the elements of your managed system are. So what you'll see is first, the logical representation, and then the physical representation. The third piece is the management component for it. So let's start first with the logical representation. The logical representation for a system is under /systems. These are represented in first what we call a collection resource. This is basically a group or an array of the objects. And then the singleton resource is a sub-element of that. So you'd see the collection resource represented as /Redfish/v1/systems. And then the singleton would be /systems/ID, which would be whatever the name of that particular system is in a URI compatible ID. So say we have /systems/unique identifier. Underneath that, that pattern repeats. So we could have subordinate resource collections, and these are all specified in the schema as to these particular patterns. So these are all well-known URI patterns defined in the schema. This is a requirement, not necessarily for the CSDL or JSON, but it is required for the YAML schema. So those requirements are propagated throughout the system. So we'll see /systems, /system ID, /processor ID. So that is a well-known URI replicated throughout the environment. This is not a comprehensive picture, obviously, but you can see the basic structure that we have here. So that's kind of how the logical view is constructed. The physical view is structured similarly. The physical views for all of the objects in the Redfish hierarchy are represented under a /chassis. So similarly to the /systems collection, /chassis also hangs off the service root. So that'll be at /redfish /v1 /chassis. Under there, you will see representations of power, thermal. You'll also see objects that are included in the chassis hierarchy and that we would expect to see and that you would expect to see modeled and represented in a physical environment. So there would be an instance of a chassis, such as an enclosure, and within an enclosure, a drive, for example. One thing to note here is that the drive would be contained, while it would be contained in the physical hierarchy, it would be logically managed out of the logical hierarchy. So it would be contained in the chassis, but managed out of the storage instance in the logical hierarchy. So there's a couple other things of note here in the basic Redfish hierarchy. I mentioned at first is the /managers resource. This is very important from the server perspective. This is where you would expect to see the BMC modeled. For other types of devices, this may be a software manager. It may also be an embedded device manager or the like. These other pink or red services are all of the rest of the services available to supplement these models. This includes things like log service, a task service, an event service, account service, a session service, all of the things you basically need to create a full-fledged management environment within the Redfish service. That's basically how a Redfish system is constructed. As we move on to the Swordfish view, let's look at how we extend this environment to cover storage. When we add storage in, we have a lot of those same patterns repeating. But as you can see here, instead of having /systems as the logical view for a storage system, off of the storage root, we now have /redfish /v1 /storage. That is where we add the logical representation for a storage system. And so out of this storage collection, we have the usual suspects of subordinate objects for a storage system, such as volumes, storage pools, controllers, and then consistent with the model we had in systems, we have references to drives. The drives stay contained within the chassis, consistent with the model we just talked about from a Redfish. So chassis still becomes the place where all of the physical representation, which contains drives, but the drives, as in the previous model reflected, drives are contained in chassis, but are managed in the logical representation. And in this view, they're actually managed in the storage pools. So drives are then contained and used by storage pools, carved up and into volumes or into files, file systems. So that's the same pattern that we saw on the Redfish side, repeated again here in the storage hierarchy. One of the other things we've added in the Swordfish view is this notion of a feature registry. The feature registry is how a Swordfish implementation can advertise the functionality to clients in a coarse-grained way of the capabilities that it supports. For example, it can advertise that it supports discovery, block provisioning, replication, all sorts of capabilities that a client may be looking for to understand what capabilities a storage device can support. The other piece we talked about a little bit about is what is adding support for NVMe and NVMe-oF. As we went to look through adding capabilities for NVMe devices, one of the things we found was very, very similar concepts emerging from the NVM Express world. However, they had slightly different names, but the underlying representation and concepts were similar. So what we've got down here in this lower right-hand box is a mapping of how we have reused these objects from the traditional storage devices into the newer NVMe usages. So where we have historically had a storage, upper level object being storage, in the NVMe world, that's now a subsystem. So we have mapped those two objects together. Similarly, working down the tree, where you have a subsystem that now contains controllers. A controller is mapped to a storage controller. A volume is mapped to a namespace. A storage pool is mapped to an endurance group or an NVMe or an NVM set. And the chassis and drive consistently also continue to contain the physical entity information. For details on how all of this works and the exact mappings of that, we have created a document that is called the Swordfish Object and Mapping Guide. It's available at SNIA.org/swordfish and contains all of the details. It also includes all of the additional properties we added that are specific to NVMe. There are also NVMe specific profiles that we have developed. These profiles cover the required and recommended properties that implementations should implement in the Redfish and Swordfish layers for NVMe drive implementations. The team is currently working on adding new profiles to support additional NVMe device types, including JBOFs, EBOFs, and arrays. All right, moving forward a little bit in the modeling, we look at adding additional complexity in fabrics. So these boxes down here on the bottom are red because these are the basic Redfish fabric model. When we start looking at NVMe-oF, we leverage this connectivity and again map the NVMe-oF fabric and access rights to a portion of the fabric model. The Redfish fabric model has two basic capabilities built in. One is mapping authentication capabilities, and the other is mapping connectivity. This particular picture talks about mapping the authentication and access capabilities, which uses the connections, endpoints, and zones model. That's what we have mapped to date in the NVMe-oF space. The next piece in the fabric model covers the connectivity model. This is where you see the other portion of the fabric model, which uses a combination of these switches, endpoints, and zones. This leads in to the next piece of work that the Swordfish team is teeing up to work on. And this is how we're doing it. A lot of the work we've talked about with NVMe and NVMe-oF and the work to date has been through an alliance partnership with both DMTF and the NVM Express organization. As we start looking at more general purpose fabric management, we're extending the work through a new alliance with the Open Fabrics Alliance. The alliance agreements allow us to basically take the technical teams from the organizations together to align existing work and avoid duplication of content that has been developed in other organizations. It's really a great way to allow us to accelerate development and adoption and avoid any duplication of effort that's already happened in the other organizations. It also allows us to bring content experts together in new and unique ways. And we can focus on just creating new content in each area as needed. We've talked a little bit about Redfish having that fabric management. Clearly, the storage fabric management expertise and knowledge is in SNIA. But what we're bringing new to the table now is open fabric management capabilities coming from the Open Fabrics Alliance. What this really means is we have a lot of expertise in pure fabric management and across a lot of new different types of technologies, managing fabrics and looking at different types of fabric technologies, and we bring that in and integrate that into that Redfish and Swordfish ecosystem. Here's kind of the work items and what we're starting to work through now. In the OFA organization, there's a group called the OFMF, which is the Open Fabrics Management Framework Work Group. They're working on building the Open Fabrics Management Framework, or the OFMF, and is being defined to be a Redfish and Swordfish based framework. That framework is also being defined to ensure that it supports every potential type of fabric, including support for any future unknown fabric types as much as, to the extent possible. So what we're doing is looking at what are existing and potential future client-driven use cases to integrate with the system, and then looking how we can map the Redfish and Swordfish existing ecosystem together with functionality provided by this fabric management framework, together with any NVMe-oF instantiations, as well as other fabric management instantiations, step through those and help develop the design of that management framework, as well as extend Redfish and Swordfish where needed. So it's a very iterative process. What we're doing right now is actually working towards a proof of concept targeting the November timeframe and having an initial POC at Supercompute later this year, with hopefully an initial demo even before that at SDC in September. So talking a little bit more about what we expect the architecture of this to look like, we're really, again, trying to say, how do we take this Open Fabrics management framework and bring that into this standards-based enterprise and data center management ecosystem, which is Redfish and Swordfish. I talked a lot about this earlier and said we have this base Redfish architecture for fabric management and connectivity. That's exactly where we want to plug this Open Fabrics Management Framework into. We're looking at how do we take this base connectivity model in and integrate the Open Fabrics Management Framework in as the instrumentation with this Redfish Fabrics model as the top end of that instrumentation. This is the type of functionality that we're targeting to include in this end-to-end functionality. As you can see, there's everything from endpoint configuration requirements, which brings in that base Redfish fabric management capability, to layered workload and storage fabric management use cases through the layered fabric management stack over here on the left side, starting with base level fabric instrumentation, starting with fabric setup, authentication and routes, and moving up the stack to addressing firewall partitioning, route and topology management, and getting that base fabric configuration management in place so that we can add layered value add, performance automation, tuning, workload analysis, workload management, and feeding all of those in through a Redfish and Swordfish interface up to additional composition tools, orchestration tools, and resource managers above the APIs. So that's a little bit about the architecture, the design, and what we're trying to accomplish through this alliance agreement. So I hope that gives you a good sense of what we're trying to do. And here's a little bit about where to find more information. Here's the pointers for all three organizations. Please take a moment to rate this session and give us 5 stars. And please let us know any feedback you have. Thanks.